Okay, Assalamualaikum warahmatullahi wabarakatuh, and good day. Okay, so I want to recap before we continue. Last week we learned about real power, reactive power, which is Q, apparent power, okay, then a complex power. Actually, you can differentiate it by bold this S. Okay, so this is complex power. Then power factor, okay, PF, P dot F dot power factor, and lastly instantaneous power. So there are 1, 2, 3, 4, 5, 6 things you need to know when it comes to AC power. Okay, so from this power, what is the relationship? Okay, from P, if the P, okay, P is for at load, P is always positive. Okay, if there is a P value, it means that there is power used by resistor. Okay, that is P means. Okay, the power is used by resistor. And for Q, it can be positive or negative. Okay, for positive means that the power used by inductor. How about Q negative? Okay, power is supply. Remember, in DC, I teach you the basic. If positive means that use or absorb, if negative means that it is supply. But this one for C, okay, Q for negative is means that it's supplied by C. Okay, make sure that you know that for source, okay, for source, okay, and current, okay, this supply real and apparent power. Okay, for this one, okay, it supply both real and apparent power. But for C is only supply apparent power. Okay, make sure you differentiate it. Okay, for this source, okay, it supply both P and Q, but for C is only supply Q. Okay, then based from this one, and then you have S. Okay, complex power. So basically S is just complex, not complex, but apparent power. So this one always positive. So positive, and this show the power used or used by P, R, L, and C. Okay, so LC is so depend. So this one is reactive component. Okay, reactive component. So basically S is just overall view of all the power used. Okay, but it is not enough. Okay, because use or supply. So it is not enough. The information is not enough. So how about S? Complex power. S. So just bold it. Okay. So S. Okay. S can be. Okay. S is always positive, but for the angle, okay, it can be S. Okay. S is this S. Okay. S angle positive. Okay, positive, and then S can be negative. Okay, this one is the theta equals to theta V minus theta I. Okay, okay, what is the meaning of this? If the theta is positive, okay, positive means that, okay, positive theta means that it is inductive circuit, inductive load, okay, inductive load if the theta is positive, okay, and if the theta is negative, you know that this is capacitive load, okay. So you can say that inductive circuit, or the circuit is inductive, or the circuit is capacitive based on the apparent angle, okay, the angle of the apparent, okay, apparent power. So based on this, you need to know what is the characteristic, okay. Then power factor PF, okay, so basically the same thing, because PF is basically cos theta, okay. Okay, if the theta is positive, meaning inductive, okay, so you need to know. But the problem is, even though the cos, okay, for example, cos 30 and cos negative 30, okay, cos 30 is 0.87, and cos negative 30 is also cos 0.87. So you cannot differentiate inductive or capacitive, okay. So when it comes to power factor, okay, when you do calculation, make sure that you mention the power factor. I remember capacitive, okay, and inductive. I mentioned before in AC circuit, the basic AC circuit. There are inductive type of circuit and there are capacitive type of circuit. Okay, the circuit is more inductive, means that there are more inductor than the capacitor. And if there is more, if the angle is negative, means that the circuit has more capacitive component than the inductive component. Okay. So to write, for example, what is the PF? So basically, you have to, for example, you calculate everything, okay, you get 0.87, and in your calculation it is positive. You have to say the PF is 0.87 lagging, okay, and if it is negative, the power factor is 0.87 leading, okay. So you have to make sure to mention leading and lagging when it comes to power factor. So PF is equals to cos theta, okay. So theta can be either positive or negative, okay, and if it is positive, means that the character of the circuit is inductive, okay, character or characteristic, okay, characteristic is inductive. And when the theta is negative, it is okay, this one is capacitive, okay, the characteristic is more towards capacitive, okay, that is the character. How about the power factor? So for inductive, you have to say that it is lagging, okay, you have to say that the power factor is lagging. But for negative, you have to say that the power factor is leading, okay, lead or lag. Make sure you know, okay. And then lastly, you need to know how to draw, okay, what is mean by leading and what is mean by lagging. So how to draw is basically, okay, when it comes to term leading and lagging, you have to make voltage as a reference, okay. For example, this one is V. Lagging means that the current is the things that you analyze. Okay, voltage as a reference. Okay, means that for power factor lagging, the current is lagging, I. Okay, lagging. Okay, for leading power factor means that the current is leading. Okay, I. Okay, this man is leading and lagging is the current. Okay, and the reference is the voltage. Okay, make sure always use the voltage as a reference, and the leading and lagging is the current. Okay, so for this I lead, I lag V. This one is I lead V. So when it asks you to draw, make sure you draw it properly. And this is the theta. Okay. So this is how you use all this information. Okay. Then don't forget the power triangle. Okay, you need to know how to draw this. Okay. This is the phasor diagram actually. Phasor diagram. Oops. Okay, I delete this first. Okay, this one is phasor. Okay, this is phasor diagram. You need to know the phasor diagram is for voltage and current, and for power triangle is for P, Q, S, and lastly PF. Okay, so how you put all of this information? Okay, remember P always goes to this side, to the right. Okay, P. Then Q, if it's positive, goes here. This is Q. And then this is S. And this is the theta. Okay, this one is inductive, because the angle is positive and Q is positive. Okay, theta is positive. Why is called inductive? Because theta is positive, Q is positive. Okay, so S apparent power doesn't show anything, but S complex power is basically this. Okay, S angle theta. Okay, so you can know that the circuit is inductive by using all of these characteristics. Okay, theta and Q. How about capacitive? For capacitive, P is also always go to the right, but for capacitive, Q goes down, negative Q. And S, okay, S goes here, S, and this is the theta. Okay, theta always at this side. Okay, theta, theta. So this one is capacitive. You need to know to differentiate the capacitive. The capacitive is theta is negative. Okay, but negative, Q is negative. Okay, and S equals to S negative theta. Okay, make sure you know the power triangle for inductive type and capacitive type. How about instantaneous? Okay, so remember the formula P T equals to P. Okay, P is real. Okay, this one, all of it is real, no imaginary part. So PT is just P plus P cos 2WT. Don't forget the 2. Okay, it's important, don't forget it. Minus Q sine 2WT. Remember, you need to know the formula because you have to extract this and this and this. P, Q, and W. And then sometimes they ask you to find PT. Okay, from this you can know what is your, you can draw the triangle. Okay, draw the triangle waveform, triangle power. So if the Q is positive, you have to know how to draw it again from this equation. Okay. And the theory is also you need to know. Okay. This one also don't forget. So Pantagoras Theorem. Okay. P, Q, S, and how to get the S apparent power from P and Q. So P squared. Okay. P squared plus Q squared, and then square root. You get the apparent power. Okay. Also you need to know how to get angle from P and Q. So tan theta Q over P. Okay, remember all of this is the identity TOA. So okay, so if you have the angle like this is the 90 degree. Okay, to opposite, this one is adjacent, this one is hypotenuse. Okay, so this is the angle. So tan, okay, tan theta is basically OA, TOA, opposite over adjacent. Sine, okay, for this case is P, in this case is Q. So Q over P. Okay, sine is equals to, sine theta is equals to, so opposite. So O divided by hash, or and then equals to, so this one is actually S if you use power triangle. So hash, so basically Q divided by S. Okay, same as cos. Cos is K, adjacent over hypotenuse. So you need to memorize that. Okay, that is all the information regarding power. So this is the theory. Okay, you need to know what is real, reactive, and apparent. Okay, also I forget to mention that real power is the real power. Okay, that is why it's called real power. Okay, the power that is used by the load. Reactive power is not a real power. Okay, it's like a reactive. Okay, it's reactive to react to the load. Okay, so it is not being used. Okay, for example, I said before that for a power supply, for example, this one and this one, okay, it supply P and Q. Okay, so P and Q. But if you adjust, remember that Q can be positive and can be negative. If you balance it out, Q can be 0. So this is not a real power. It's basically react to the load. So you can cancel the Q. So if you design the system perfectly, okay, your power supply only supply P. Okay, no need for Q. No Q. Okay. So this is called power factor correction. Okay. So what is power factor correction is basically, okay, you have P. Okay, P cannot change because it is a real power. But Q, okay, for example, you have this, okay, Q. Then you try to reduce it. Okay, you add capacitor. This is inductive. Okay, this is capacitive. Okay, so then you try to adjust it until you get Q is 0. Okay, this P remain the same. This is called power factor correction. It will be discussed in our next class. Okay. So, okay, you can see here. So total power is basically combination of reactive and real power. So I mentioned already this one. Okay. So this one also I already mentioned. Okay, now we go on to a problem. Okay. So we will discuss this in our next class. Okay. That's it. Thank you.